We are covering the unit hydrograph and the storm hydrograph for the FE Civil exam. This topic is found in the Civil Engineering section of the NCEES FE Reference Handbook. A unit hydrograph is defined as the direct runoff hydrograph that results from 1 inch, or 1 centimeter, of effective rainfall spread uniformly over a watershed for a specific duration. Think of it as the watershed's unique fingerprint for how it responds to a single unit of rain. The key components you'll see on a hydrograph plot are the rising limb, the peak discharge, the falling or recession limb, and the time base. The core principle for the exam is linear superposition. This means if you know the response to 1 inch of rain, the response to 2 inches of rain is simply twice the flow at every point. Let's walk through a typical exam problem. You will be given a table of time versus discharge for a 2-hour unit hydrograph. The peak discharge on this table is, say, 150 cubic feet per second. The problem then states that a storm produces 3 inches of effective rainfall over a 2-hour period. To find the peak discharge of the resulting storm hydrograph, you simply apply the principle of linear superposition. You take the unit hydrograph's peak flow of 150 CFS and multiply it by the 3 inches of effective rainfall. This gives you a storm hydrograph peak of 450 CFS. The most common exam trap is the difference between total rainfall and effective rainfall. The unit hydrograph method only applies to effective or excess rainfall, the water that actually becomes direct runoff after infiltration and other losses are accounted for. An exam question might give you 4 inches of total rainfall and a phi index of 0.5 inches per hour for a 2-hour storm. First, you must calculate the total loss, which is 0.5 inches per hour times 2 hours, equaling 1 inch of loss. Then you subtract this loss from the total rainfall to find the effective rainfall, which is 4 inches minus 1 inch, giving you 3 inches. You then use this 3-inch value to scale the unit hydrograph. Another common confusion point is baseflow. The unit hydrograph represents direct runoff only. If a problem gives you a constant baseflow of 50 CFS and asks for the peak streamflow, you must add this baseflow to your calculated peak direct runoff. So in our example, the peak streamflow would be 450 CFS plus the 50 CFS baseflow for a total of 500 CFS. A simple way to remember the core concept is this phrase: the unit hydrograph is for 1 unit of rain. Just multiply by the real effective rain to predict the storm's pain. This helps connect the term unit to the number 1 and reinforces that the process is a simple multiplication by the actual effective rainfall depth. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.